Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody from the future to the final lecture. So I have just a tiny little bit to finish on the implementation of RumbleDB and JSONic. Then I'll move on to wrapping things up on the very high level, and then we have a quiz game in the second part of the semester to celebrate the end of the semester. So. What I need to tell you is about the physical implementation. So I told you about the idea that JSONic is a high-level language, just like SQL. And it means that JSONic is exactly the same if it's on a laptop, if it's on a data center, if you're querying kilobytes of data, if you're querying petabytes of data, if you're querying JSON, Parquet, CSV, anything, it looks exactly the same. But that means that on the physical layer, the implementation layer, this is all the hard work that must be done, and that was actually done by previous students. So what's hidden that the users do not see is how all of this is executed. And we have plenty of execution modes, so ways that it can be executed, and the user doesn't see anything. The only thing they should notice is fast or slow, but this is pretty much it. So the simple cases are the cases where we have empty sequences or simple values, like sequences of just one items. When we know in advance, before executing the program, we can predict that an expression returns exactly one item or at most one item, that we can implement with simple good old methods in Java. It's implemented in Java in this case. So this is the simple case, right? In fact, the 1 + 2 × 3, we don't even bother with the complexity of Spark or anything. We just implement it as a simple method call. Then we have the sequences of more than one item. If they're small enough, so it's not like billions, but just like 1,000, maybe 1,000,000 still fits on a machine, then we iterate. That's called the Volcano iterator. It means that we have an API that basically has methods like open, has next, yes, no, and then next, and then you pull the string, one by one you pull the items. Has next, next, has next, next, has next, next, has next, then maybe it returns false, and then you're done, and you close the iterator. So this is the way it works. It's called the Volcano iterator. You just do item by item. You stream your way through the item. And when you have filters like this, for example, you have 1 to 10, and then you filter the numbers that are even. Again, that's going to be with next, 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 next. You do it item by item, and every time you check yes or no, is it even? And then at the end, you will only get those that are even, right? So of course, the user just sees the final sequence of items in the end, but internally, this is how it's implemented. So that's the case where it's small enough. Now, what if it's bigger? Like, for example, I'm reading some JSON file from the data lake, and I open it with JSON file. So now, logically, it's just a sequence of objects, right? So for the user, it's simple. But what's actually happening behind the scenes is that that file, which might have a billion lines of JSON that might be heterogeneous, we squeeze it into an RDD. In Spark, we just read the whole thing as an RDD of strings, and then we parse them as JSON. And then we have an RDD of JSON objects, but heterogeneous, right? Which is totally possible. It's called polymorphism, if you know what that means in object-oriented programming. So it means it's totally fine to have an RDD of JSON objects, even if they are heterogeneous, right? And then when you iterate, for example, .countries, that's just a flat map, right? We just run a flat map against that RDD. But you see the magic. The user does not see anything. The user doesn't see the RDD. The user doesn't see the flat map. It's all hidden. The user just sees the query and the sequence of items, right? Unboxing is also a flat map because everything is always flattened again. UDF means user-defined function. It's just a detail in Java that we need to write some Java code and ship it over to the flat map transformation. Then distinct values, we can also ask Spark to do it for us, right? With some other transformation. But you see now, we learn Spark and the API as a user, but now it's a different perspective because that Spark here is completely hidden. The only people who actually saw that Spark are the engineers that implemented RumbleDB, but the users of RumbleDB do not see that anymore. And that's how it works magically on billions of objects, right? Then what happens if the data is valid? For example, we open for a Parquet file, and it's already valid. In that case, we will not create an RDD internally. We will create a data frame because you know that a data frame is when the JSON is valid, right? Or when the data is valid. But you see that for the user, it doesn't make a difference. The user still sees a sequence of objects. They will still see a sequence of objects, but it will just be faster because the data frame takes less space than an RDD and the execution is going to be faster. So it's really important. On the logical level, the only thing the user sees is that it's faster. On the physical level, we just use the data frame instead of an RDD, but that's all hidden from the user. So you see, if it's heterogeneous, we just use RDDs of items. And if it's homogeneous, then we use data frames. We also use data frames for sequences of integers, sequences of strings. It's just a data frame with a single column, right? For whom is that clear? Okay, that's all hidden, right? It's just the implementation. So the summary for expressions is that we can have a direct Java method call if it's a single item. We can iterate our way sequentially. That's the streaming that I told you about. Next, 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 if it's small enough. If we open a JSON file that isn't valid, then we just use RDD and transformations. If it's a Parquet file or we know that it's structured or we validated it, then we use data frames and data frame transformations. And finally, for some cases, and that is new, we might also convert to Spark SQL. And an example here is that when you have an iteration on some Parquet file, we know that it's Parquet. I should have put Parquet here. This actually will be converted to Spark SQL. It means that also that will be converted to Spark SQL as well, right? So this is also something that just made it even faster than it already was to also use native Spark SQL behind the scene. Again, I insist, the user does not see the Spark SQL. It's all hidden. The only thing the user sees is it's faster, okay? Then what about the execution of the flowers, right? Because I was talking about expressions. What about the clauses? So you know that the clauses in flower expressions, they manipulate these tuple streams, right? That it flows top down, and every clause takes a tuple stream and outputs a tuple stream, right? It doesn't matter if it's selection, projection, grouping, joining, generic, and so on. So what happens in order to implement this is that if we have a JSON file, so we create an RDD, right? If we have an iteration, it's heterogeneous. So what we do is that we squeeze that RDD into a data frame with a single column. That column corresponds to the variable. Generally, we have one column for every variable in the flower variable. And then we just serialize it to binary. It means it's just zeros and ones internally. We don't really have a choice because we cannot make it a structured type because it's heterogeneous. If it was homogeneous, we could really have struct type and then have all typed. But since it's heterogeneous, we just need to just make it bits. And it's just a serialization to bits of all the objects. But still, it's fast enough. Then what happens is that if you have another 4, that creates a second column with the name of the variable. And in that case, we detect it's a string. The type of country is a string. So we also use a string type in the data frame. And then where is, again, going to be a filter on that data frame, right? We interpret that as a filter. Then a let will add yet another column. Here we might automatically detect that it's always a string. So we put a string type for that column. And then when we return, this is the end of the flower. So now we convert it back to some RDD of items. But again, I insist, what you see here, all this animation with the data frame, the user doesn't see that. It's all hidden. The only thing the user sees is the JSONic code, and they are reading files with sequences of items, and the tuple streams flow around in the flowers. But since it's all done on RDDs and data frames, then it's fast and parallel on the cluster. For whom is that clear? Okay. So of course, I'm not going too much in the details, right? It's just high level. So in summary, for the flower, if we want them in parallel, we are going to use data frames, one column for each variable, and then transformations on the data frame. So every clause has a different way of transforming the data frames. However, what if we have a small flower? If we have a flower that only iterates like on 1,000 items or 1,000,000 items, in that case, it's too small to justify using data frames. We could, of course, use data frames, but it's going to be too slow because of the latency. So if we know, for example, in the first case above, there's only 100 items. 100 items is ridiculously small for big data. So in that case, we will not even bother with the data frame. In the first case above, we'll just also iterate 1, 2, 3. We'll just iterate on the tuples of the values that I can take. And that will be fully local on your laptop without Spark. And again, transparently, if it's small enough, we just do it iteratively on the laptop. And if it's large, then we use data frames and RDD. This is all chosen automatically by the system. Now, what you get internally is that when you parse this query here on the top left, you get some tree. And then the engine, RumbleDB, is going to do all of the work. It's all implemented that automatically detects is that a sequence of items, a stream of tuples, and so on. And it automatically figures out where to use data frames, where to use RDDs, the transformations to use, and so on. All of that is done automatically by the engine in a way that just works. And every year we manage to make it faster. We release now probably once a year or so. And it doesn't change the way it's used, but it's just becoming faster every year as we optimize more. Here's an example of a simple query that's parallelized. So we have a JSON file that's internally going to be an RDD. Foo bar, that's flat maps, right? So it just creates RDDs. And then the sum can be pushed down to Spark. Push down is what we call when you delegate to Spark the execution. And the sum can also be done with a reduce action on Spark. Okay, so that also works. These functions like sum, max, min, average, that are JSONic built-in functions, they work on billions of items without any problem. It's automatically going to do it in parallel, right? So the modern architectures, who heard of data lake? Who heard of lake house? That was a term that was coined in the CIDR conference 3 years ago, I think, by the same people who invented Spark. It's the lake house. The idea is that it merges a data lake with a relational database management system. It has everything in the same hood. And it also supports machine learning. So it has the whole stack from the preparation of the data, putting it in tables, making them faster, and then learning and training data. And in fact, JSONic works with that kind of environment. For example, the cleanup can be done with a schema. You can have a data set that is not clean. Then you can define a schema in JSON. That's what you see on the top. And then you can validate. There's a validate expression that is going to validate that it fits the schema. And RumbleDB will automatically then promote that to a data frame. When you validate against the schema, internally, it's going to be then suddenly a data frame. So validation for the user just makes it faster. Plus, once you have validated it, you can save it as Parquet, as Avro, and so on. So RumbleDB can also be used to convert and validate JSON, then save it to Parquet. It's like a Swiss Army knife of manipulating data. And it also does machine learning. That's not in the scope of the course, of course, but that was a beautiful master's thesis a while ago, where we can actually take build data frames like these, build sequences of objects with the features and the labels, and then we use function items, those that I said are out of scope. We use function items to implement the machine learning models, and then we can train again. You recognize the flower expression here using the JSONic language. Okay, so just to show that it does the whole stack. And in the next update that should be released soon, we will even support updates, meaning that you can modify the data and it works. We heard of the Delta Lake of Databricks. So the Delta Lake is a way of having a data lake to which you can write. It automatically handles the write and the modifications of the data in a very smart way. And so in the next version of RumbleDB, you will even be able to modify the data through systems like the Delta Lake. Okay, but that's completely out of scope. I'm just saying that it exists. Okay, so that was the last slide ever of the material. Any questions? Yes? Maybe we can use the...
Maybe I missed at the beginning the concept. So if I would be the user, I have 1,000 JSON files, let's say from a log. And is it I connect to a directory and read them all, and they will be bounded to the RumbleDB, or is it one by one?
No, it's not one by one. In fact, if you have 1,000 files, just have them on the data lake, put them on S3, maybe they're already there. And what you do is that you use this the file to open the data. So this JSON file here, it can also be with a star. that you open all the contents of a directory, just like Spark. So if you say, for example, JSON file and then some path /star.json, it's opening the 1,000 files without any problem and in parallel. So Spark is going to take care of it. There is no extra effort. Just put it in the data lake and then you directly open it like this.
And can I dump from them the schema?
You can validate with the schema, yes. Absolutely. You can validate that in parallel, and then it can create a data frame, and you can save it back as a Parquet file also on the data lake.
Okay.
The full ecosystem, the full cycle.
Thank you.
Yeah. Thank you. All right. Any other questions? All right. Then let's wrap up. I'm going to end the recording here.